Hello there! Ever wondered how to visualize sound? Today, we're diving into the world of audio waveforms in React Native. We'll show you how to display a cool visual representation of your recorded audio. This script covers getting audio data and rendering it as a waveform. Let's get started. First, we need to record audio in our React Native application. There are libraries like Expo AV or React Native Sound that make audio recording easy. We won't cover the exact recording setup in detail here, but assume you have a function returning the audio data as an array of amplitude values. These values represent the sound's intensity over time. Now we have audio data, we need a way to display it. We'll use React Native's View component and style it to look like a waveform. The waveform is essentially a series of vertical bars. The height of each bar corresponds to the amplitude of the audio at that point in time. To draw our waveform, we'll iterate over our array of audio data. For each data point, we'll create a view. We'll give this view a specific width. This width determines how many bars are in our waveform. The height of the view is crucial. This height will be proportional to the amplitude value at that point. Higher amplitude means a taller bar. We'll use styling to achieve this visual effect. We'll also give the bars a background color. This color makes them visible on the screen. We use map function to loop through the array of audio data and return the appropriate JSX code. Next, we'll encapsulate our waveform visualization logic into a reusable React Native component. This component takes the audio data as a prop. Inside the component, we'll perform the mapping and rendering logic. This makes it easy to use the waveform display in different parts of your app. Now, let's talk about scaling and normalization. Audio data often comes in a wide range of values. We need to normalize these values to fit within our screen's height. Normalization involves mapping the audio data range to a smaller, more manageable range. For example, you might map the audio values to a range between 0 and 1. Then, you multiply these normalized values by the desired maximum height of your waveform. We will use a simple scaling function to make the waveform look good. Remember to consider performance implications. Large audio files can lead to a lot of data points. Rendering all these points directly can slow down your app. One optimization is to reduce the number of data points displayed. You can sample the audio data and only use a subset of the values for the waveform. This helps improve rendering speed without significantly affecting the waveform's visual representation. Experiment with different sampling rates to find a good balance between performance and detail. You can also cache the generated waveform component to avoid re-rendering it every time the component updates. Another optimization is to use React Native's flatlist component if you have a very long audio file. Flatlist is optimized for rendering large lists of data. This is another useful way to boost performance. Finally, remember to handle different audio formats. The audio data may come in various formats, so ensure your scaling and rendering logic can handle different data types. If the audio data changes during playback, you'll need to update the waveform in real time. This involves re-rendering the component with the new audio data. In this situation, consider using animation libraries to create a smooth, animated transition between waveforms. Using animation libraries can improve the user experience. And there you have it. We have covered the basics of displaying audio waveforms in React Native. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more React Native tutorials. Consider supporting the channel by becoming a patron or donating to help us create more content. Your support keeps us going.